I will teach what is a dimension of vector space. Dimension of vector space is related to basis. Let B be a basis of vector space V. Number of elements of B is finite if number of elements of B is finite. We can say our vector space V is finite dimensional. B is a basis of V. We find out a basis and that basis is B. B is a basis of vector space V. And we count the number of elements in B. Number of elements in B is finite. Then we can say our vector space is finite dimensional vector space. And number of elements of B is finite dimensional vector space. And number of elements of B is called dimension of V. Dimension of V is number of elements in the basis. That number is dimension of vector space. So, first we take one vector space and we find out the basis of that vector space. That basis has, if that basis has finite elements, then we can say that vector space is finite dimensional vector space. If it has number of elements of B has infinite number of elements, then we can say infinite dimensional vector space. And dimension of vector space is a number. That number is number of elements in the basis of R2. Basis of vector space. Corresponding vector space. So we take R2 means a basis of R2 has how many elements? We find out. That number is dimension of R2. So you can take any vector space and that you find out the basis of that vector space. That basis has finite number of elements. You can say finite dimensional vector space. That basis has infinite number of elements. Then we can say that vector space is infinite dimensional vector space. And that basis set has how many elements? Number of elements of that basis set is dimension of V. Okay? Dimension of V is number of elements of B. So you can take R2, one vector space R2. We know 1001 is basis. So far 2. We already show that 1001 is basis of R2. Otherwise check it out. 1001 is linearly independent and every element in R2 can be expressed as linear combination of 1 0 0 1. Then we can say 1 0 0 1 is basis of R2. We already proved. So we know 1 0 0 1 is basis of R2. What is number of elements in this basis element? 2 elements, 1 and 2. So dimension of R2 is number of elements of basis set. In this basis, we have 2 elements. So dimension of R2 is 2. So every basis of R2 have 2 elements. So we can say dimension of R2 equal to 2. You can find out more basis of R2, but basis set has 2 elements only. Exactly 2 elements. So we can say dimension of R2 equal to 2. Next you can take a polynomial set. P2. Set of all polynomials degree less than or equal to 2. We already show that 1x square is basis of P2. 1x square is basis of P2. We already shown. Otherwise, you can check it. This is linearly independent and every element in P2 can be expressed as these 3 elements. Every element in P2 can be expressed, linear combination can be expressed as a linear combination of these 3 elements. So we already show that 1x square is basis of P2. Basis of P2. So dimension of P2 is number of elements of basis set. How many elements? 3 elements. So dimension of P2 is 3. Next, you take Rn. E1, E2, etc. En, where E1 is 1 0 0, E2 is 0 1 0 0, etc. En is 0 0 1. So we already proved that E1, E2, etc. En is basis of Rn. We already show that E1, E2, etc. En is basis of Rn. Otherwise, you take one exercise, you show that E1, E2, etc. En is basis or not. So we have to prove that one is these elements are linearly independent. Second one is every element in Rn can be expressed as linear combination of B. That is span of B equal to Rn. We know E1, E2, etc. En is basis of Rn. So dimension of Rn is number of elements of basis element. How many elements? N elements. So we can say dimension of Rn is n. I will say one more example. You take a Pn. Pn is set of all polynomial degree less than or equal to n. In this case, we take a 1x etc. x square etc. x power n is a subset of Pn. We already show that this set is basis of Pn. Otherwise, you can check out this is linearly independent and every element in Pn can be expressed as linear combination of these n plus 1 elements. So we know 1x x square etc. x power n is basis of Pn. So dimension of Pn is number of elements of basis set. So this set has x power 1, x power 2, etc. x power n. So n elements, and this is a 1 element. So total elements are n plus 1 elements. Total elements is n plus 1 elements. B has n plus 1 elements. So dimension of Pn is n plus 1. You already show that 1x, x square, etc. x power n is basis of Pn. So number of elements in B is n plus 1. So dimension of Pn is n plus 1. Okay.